In this section 5.4, we are going to solve our quadratic equations by doing something called completing the square. We're also going to write our quadratic equations in vertex form. So, first thing we're going to do is use the square root property. So, to solve a quadratic equation, we could take the square root of both sides of the equation. And when we do that, we need to consider both the positive and the negative square roots. So you are going to have a plus minus answer when you take the square root of both sides. So the first thing we have to do when we are trying to use the square root property, or being able to take the square root of both sides, is we have to isolate the x squared. So the first thing you're going to want to do is add 4 to both sides, and then divide by 3, so that you have the square root all by itself. Now you can take the square root of both sides. It's going to be a plus minus answer. And then you do have to simplify your square roots, just like we did before. And so you're going to have to recall that. This is, if you want to see my prime factorization, there's a pair of 2's. So 1, 2 comes out, and the 2 times 3 stays in. Sometimes when you have a middle term, such as the 10x, you have a trinomial, you might have to factor this first. That's called a perfect square trinomial. So I write the 2 factors like so. And then I can take the square root of both sides. What's left over when you take square root is just what's in underneath the radical. Simplify that. Square root of 27. So if you have to do your prime factorization tree, do that. 27 is 9 times 3. Square root of 9 is 3. So square root of 3 is still inside. And then I must move the 5 over to the other side. And you do that by adding. So you end up with 5 plus or minus 3 root 3. Okay, there are 2 examples, or 2 check-it-outs for you to try that follow these 2 examples. So pause the video, play as I'm writing, and check your answers. When you end up with integer numbers such as this one, then you must break it into the 2 parts, -4 plus 7 and -4 minus 7. You end up with integer answers. Okay? Moving on. Why do you need to consider both positive and negative square roots when you use the square root property to solve a quadratic? Because x can be negative. When you are squaring. When you're taking x squared. And this next part is called completing the square. When we complete this square, we basically are adding that third term. We have an x squared plus bx, and we want to create what we call that perfect square trinomial, so that we have that x plus 2 quantity squared, or x minus 2 quantity squared. So this completing this square is, the process is that you take that middle coefficient, you divide it by 2, and then square it. That will then be your number on the end, and you should end up with a perfect square trinomial. Here's a model showing the example that was being on the prior page. We have x squared plus 6x. We want to end up in something squared, so we take 6 divided by 2, which is 3, square it, and get 9, and there's our perfect square, and it ends up being x plus 3, x plus 3. So let's try just completing the trinomial, okay, and then we'll write it as a quantity squared. So the first thing I'm going to do is take my b, which is negative 2. I'm going to divide it by 2, and then I'm going to square it. So this is negative 1 squared, which is 1. So my trinomial is going to be that. How does that factor? Which is x minus 1 quantity squared. Okay, so what do I do again? I take my center coefficient, b, divide it by 2, then square it. My new trinomial, this is x plus, okay, and if you've got to write both things down, you write both things down. You can skip that step if you want. And just go right to the squared part. What is the number that goes in this space here? Is that number right there, the one that you generated by taking b divided by 2, in this case 5 divided by 2. Go ahead and try to check it out. Again, all you're doing is the exact same thing I just did in those two examples. Finding the third term and then writing it in a binomial squared. Hope you're seeing the pattern that is going on. How do you determine the value of b? It's the coefficient, oops. It's the coefficient of just the x term. How do you find the term needed to complete the square? It's that b divided by 2 and then square it. Okay, this does end day 1. We'll continue with day 2 tomorrow.